Welcome to MEI Numerical Methods Numerical Integration. In this video we'll be continuing to look at the Simpson's rule. In the previous video we found a formula for Simpson's rule, but there is in fact a connection between Simpson's rule and the midpoint and trapezium rules, which we're just about to prove for a particular case. And in practice it's normally easier to use this connection than the formula we saw earlier on. Now, when we were deriving the formula for the Simpson's rule in the last video, we had three quadratics that we were finding the area under, and each quadratic was associated with two strips. So if we suppose that they're the strips in question, and we're going to say that each strip has a width of h, and so that's the h that appears in these formulae, so that if we wanted to work out the trapezium rule estimate T3 for this same overall interval, then we would be dividing our interval into three parts, and each of these strips would have a width of 2h. So that gives us the 2h there, and then similarly for the midpoint rule it will be 2h again. And then for the trapezium rule we've got, so y0 is, that's the y coordinate at the top of that strip, that's y6 there, and then y1 was there, y2 was there, and so on. So for the trapezium rule we're picking up y2 and y4 as the intermediate ones, like that, and then for the midpoint rule we're going to want the ones that are the midpoints of the strips, so they're going to be y1, y3 and y5. And so we can see that 2m3 plus t3 over 3 is that expression there, and that simplifies down to the formula that we had for S6 in the previous video. So here we have part of a spreadsheet where we've entered the values that we found in the earlier example for the trapezium rule and the midpoint rule, and in column D we've got the Simpson rule figures using the formula we've just established, and we can see that in the third row we've got a figure for the Simpson's rule which is very close to the actual figure, whereas the two values for the other two methods are quite a way off the actual value. So in practice the Simpson's rule would be used in preference to the trapezium and midpoint rules. So that concludes this video on Simpson's rule, and we'll be gathering up all the things we've discovered about the three rules in the next video.